All right. Hello, everyone. Welcome to today's session on enterprise-grade connected assets, focused on device connectivity and management at scale. My name is Alex Graw. I'm Senior Product Marketing Manager for Cumulocity IoT, and I'll be your host today. As we move to the next slide, the past decade has really seen perceptions of industrial IoT go from a lab experiment to a magic bullet for all productivity gains, and finally to the foundation for mainstream digital services. For the makers of commercial, industrial, and medical equipment, IoT solutions are becoming the rule rather than the exception. With investments in IoT growing at exponential rates, OEMs that cannot provide their customers with real-time visibility into the operating performance of their assets are at risk of being permanently displaced. So as we move to the next slide, we can also see that at the same time that IoT is becoming more mainstream, the time to market for IoT connected products has also increased and nearly doubled from less than 2 years to nearly 3.5 years. So as digital services are moving from a project to a product, it increases the complexity of the deployments and the use cases for the technology. We're also seeing a constantly developing regulatory environment, particularly in the EU, and constantly evolving universe of cybersecurity threats that also increases the complexity and is extending development timelines. So as deployments scale up to the enterprise level, there becomes a greater need for an enterprise-grade platform to help manage the entire solution. So as we move to the next slide, brings up the question of what do we mean by enterprise-grade? So at Cumulocity, we've identified 6 core capabilities that we feel are critical to ease the building, deploying, and scaling of digital solutions. First, device connectivity and management at scale. So as IoT deployments grow to include a wide variety of devices and to hundreds or thousands or millions of endpoints, bespoke connectivity solutions will become unworkable. So an enterprise-grade platform has to provide a simple method for the bulk connection and management of devices throughout their life cycle. Second, data management. So obviously it's not enough to just generate data if you can't do anything with it. So an enterprise-grade platform has to remove the complexity linked to data management so that you can ensure the quality, security, privacy, and currency of your data. Third, analytics. So IoT analytics includes a wide range of techniques, including rule engines, event stream processing, data visualization, all the way to machine learning, that together contribute to successful and scalable IoT projects. So a platform must be able to incorporate all of these techniques into your digital services. Fourth, integration with any architecture or system. So an IoT platform simplifies data integration with any architecture and any system so that you can put your data to work. And it's a critical step to scaling IoT solutions throughout your organization, and in particular with external partners becoming more of a connected ecosystem. And application enablement and management. IoT solution developers need the ability to deploy and deliver IoT solutions quickly, effortlessly, and seamlessly, taking full advantage of a range of pre-configured applications that can be easily customized. An IoT platform enables you to build applications fast, scale as needed, and show faster ROI. And then finally, deploying from the edge to the cloud. So IoT solutions are deployed in a variety of environments with limited connectivity or with restricted connectivity due to cybersecurity threats. So a solution that can operate the same on the edge as in the cloud is a must. So as we move to the next slide, to better explain the value of these core competencies, we have prepared a series of webinars over the rest of 2024 to highlight each of these topics. The next session will be on September 3rd, focused on data management, and you can go ahead and sign up for that one now. But today we have a presentation from Aaron Robb, Product Manager for Device Management at Cumulocity.
Thanks a lot, Alex, for your introduction, and hello from my side. Warm welcome. Thanks for joining in. So as Alex already mentioned, today I'm going to speak about connectivity and device management at scale, and especially this last word, at scale, is key here. So I want to raise awareness about some key aspects that you need to consider when building a robust and future-proof IoT solution. And while a lot of people tend to focus on the value and how they want to provide value to their customers and think in solutions, it's also key about thinking about the underlying foundation you want to build these solutions on top of. And device management is a key aspect when building this foundation. And here I'm referencing a report published by Beecham Research, and what we can see here is on the starting from the left-hand side is that most companies are still working with rather small device fleets, so still just a few dozens or few hundreds of devices. So they haven't actually countered these pains that you will come across when you're starting to work with thousands and 10,000s of devices. Certain processes, workflows, and manual stuff still works with just working in your POC environment, just with a bunch of devices. But once you're across a certain margin, once you are working with thousands of devices, then having efficient processes and stuff at hand is quite key. And this is something that will eventually come in the future and as companies mature, as their solutions mature, and that's also what you can see here in the middle. So nearly every company expects their device fleets to grow, with 1/3 even expecting growth rates over 40%, which is quite significant. So we will face more and more complexity in that area. But that's not only in regards to the sheer amount of number of devices that you're managing, but it's also about the complexity and heterogeneity inherited by having to deal with various different device types and evolving stack you're working with. As working and operating POC is just one thing, and over just a few months or 1 year of time. But as we are speaking here about industrial IoT platforms and about industrial use cases in general, you often have to face or work with industrial assets that need to be maintained over maybe 20, 30, 40 years. That pipeline still needs to work in future as well as it does today. And at the same time, the entire IoT technology stack continues to evolve. You may or might also want to then introduce new generations of devices, of hardware, that can cope with different functionality, also where you can enable different functionality. And as all of this matures as your solution gets more and more sophisticated, also your underlying foundation needs to evolve with it. And that's also what you can see here on the right-hand side, actually. So just 7% of the companies interviewed by Beecham actually reported that they are fine and happy with their approach, but more than 90% are actually expecting some changes. 48% actually substantial changes they need to do to their approach to continue to have a future-proof basis that they're working on. But that's still on a quite abstract level. So what does it really mean on a detailed level? Which exact aspects do you need to consider, especially from a device management perspective? So when you look at the device management or the device life cycle, of course, the first thing that you need to consider is how do I actually connect and onboard my devices? And if you're starting with your first POC, that might be quite straightforward. You want to enable your new generation of machines by IoT. You want to introduce some new innovation. Then you have quite clear requirements. You can choose the perfect protocol that's suited for this exact case. But as said, you are evolving over a longer period of time, and so does also your solution and your scope. So with your next generation that you want to include, you also might come up with new requirements depending on the learnings that you made with your old solution, but maybe also with the advancements in technology in hardware, because you have more capable processing power on your device, or you have new solutions that you want to evolve. And I mean, when you created all those value-adding functionalities that you want to make available to your customers, it also does make sense to roll it out not only to future generations, but also to retrofit to older generations. Then the question arises, how do I actually connect those legacy devices that might speak some protocols that are not primarily in the sphere of IoT, or can maybe more seen in the automation space? Also really depending on the use case, because from a protocol and integration perspective, there is not really a one-fits-all solution, but rather different kind of communication protocols that are suitable for various different use cases. So maybe the bus protocols like Modbus, Profibus for the industrial automation space, or Lightweight M2M, LoRa for lightweight battery-powered resource constraints devices. And it's not only about generations of devices that you want to onboard, but also the scope of the solution that you want to build. Maybe you start digitizing your shop floor, then you just have this automation in scope, but maybe then you also want to consider the intra-logistics in your shop, in your factory, or maybe also the trucks that are providing your factory, your shop floor with the parts that will then be added to your machine, where you, for tracking, for example, use exactly those low-powered low-powered devices, that battery-powered devices, and then out of a sudden, you actually need to sorry for that. And out of a sudden, you then need to incorporate new protocols. You need to evolve your solution and your solution architecture. And that is what brings complexity, and that is also why it's super important to build on a basis that's flexible and that can be enhanced in going forward. But that's just the first step, integrating your devices. Then the question also is, you not only want to register and provision your device, but you then also need to organize it, because you then also want to see, okay, which devices and which machines have been set up for a specific customer, which have been at a certain location, or at which country, because you then need to configure these differently maybe. So also you might want to replicate a certain hierarchy of devices and of assets that you are building. So that's also something you might want to consider straight after registering those devices. At the same time, you also need to configure these devices, as already mentioned, but you also want to deploy the latest firmware version or software packages that enhance the functionality and feature set of your devices and your machines that are connected to those. But that's actually not only something that needs to be considered when connecting these devices in the first place, but then also that's actually a continuous thing, because you continuously need to ensure that the firmware is on the latest stage and the device is up to date in the end. And you also don't want to do this on a device level, but you want to do this on in parallel for thousands of devices, if you have to work with hundreds or multiple hundreds of devices, thousands of devices. So also this, again, reflects on the need for scalability in the end. And maybe you will also come across or you will probably come across a situation where these devices are actually not working as they should, be it due to hardware failures or human error or what have you, or connectivity losses. And then, especially as we are speaking about an industrial environment, it's key to have to ensure high uptime and prevent downtimes and so on, and to be able to react on a certain issue as fast as possible. And that's just possible if you have a high transparency across your device fleet. But that's not enough. I mean, just identifying the issues is nice, but you then also need to act on that. So diagnosing and being able to troubleshoot your device is also key. So it then comes to being able to retrieve log files, for example, or to remotely access your device, to be then really able to also resolve those issues, or to change the configuration or roll out a new software if the old one has a security issue or something like that. And last but not least, also the point of decommissioning comes at one point. Maybe you will just come across this 10 years after rolling out a certain solution, but the time will come. And the question is, what do you need to consider at that point of time? Just scrapping your hardware is one thing, but maybe you've attached a gateway to your machine, and the gateway is malfunctioning, or you just want to use the newer generation, but that asset still needs to be maintained for an additional 10 years. So you want to keep all that this historical data that has been generated. And you also want to keep all the information that has been mapped. So also this aspect of identity management, being able to map things, even if you're exchanging hardware, shouldn't be neglected, because at one point you need to consider all of that. So to now give you a bit of a better hands-on experience of how this could actually look like, some of these aspects that I've just mentioned, I've prepared a demo that I want to show you now, showcasing. So it's just a fictional case. You rolled out some CNC mills to your customer, and here you're setting up a new device profile. So you set up all those CNC mills. So you're adding the newest firmware version that's now available for those CNC mills. You then also check the software repository, but all required packages have already been uploaded. They are already available. You only have the configuration for North America, but you're placing them in the EU, so you need a specific different configuration for that region. For example, you can define a device type that ensures that this particular configuration will only be applied to this particular device type, to ensure that no configuration will be applied to a device that doesn't support this kind of configuration. Again, in this, considering this aspect of availability and uptime and robustness of your operations. And what you can do here is basically to create your device profile. So you're just giving it any kind of name. Again, can define a device type, and then can basically integrate all the kind of artifacts that are required to set up these CNC mills. So for example, here, including the firmware version, you can then also add all the software packages that you want to deploy, depending on what the customer has, for example, licensed for his particular machines, what he has ordered, and also add the configuration file that we've just added. And the last thing that you just need to do then is to basically start a bulk operation to roll out all these configurations, all these artifacts to all the CNC mills. Now, we just have three or four or so, but that can also be done for thousands of devices in the end. Because you probably won't do this, don't want to do this on a single device level. And all you need to do now is schedule the bulk operation and just apply all of those. And all these CNC mills are ready to be used by your customers. But here I'm showing also the case if something went wrong in the end. So some issue during the software rollout process, connectivity losses, what 1 second. Exactly. So you're facing some issues during the rollout process, and here you already get a notification. Okay, something went wrong. You directly see the details of that operation, also the history, what has been done, to get more background information to troubleshoot, and you directly also have access to, again, try to roll out the software version, but you can also directly update or delete software. And here you also, in the service tab, have the chance to monitor all the services that have been rolled out to this particular device. You see which ones are running, where you might have an issue. You also have the chance to report metrics like CPU load or RAM usage, for example, of a Docker container that's running on your device, to get then also more information. So this also needs to be supported on device level. But especially this functionality will become more and more relevant, especially if we are seeing more and more powerful devices coming up, where you can also use them for edge inferencing. If you're, for example, deploying a new model, and you can directly do the inferencing on your device, for example, for predictive maintenance cases or for quality assurance. Exactly. So now, to sum it all up, what should you now be looking for when looking for a robust device management functionality when laying the foundations, or also of course at a later stage adding functionalities? So what's definitely key is being agnostic and interoperable from a device perspective. You need to consider a solution that can deal with multiple generations of devices, multiple types of devices. Also that need to work in different kind of network conditions, be it your local network, but also maybe your cellular network where you have certain constraints. And same also applies for protocols, as new standards are coming and going, as well as you maybe want to optimize your device in the long run then also. That's one point, but of course also, as mentioned, I just talked about the device life cycle. So you want to have a solution that can actually cover the entire device life cycle. And one thing that I also want to highlight here is the aspect of being self-service. So especially if you're just starting with your POC, you have just engineers working on it that are very knowledgeable about IoT concepts. You also need to consider that this also needs to be used by then your field service engineers or some business related personas. And you'd also, if you're employing new staff, then you also don't want to have tutorials and onboarding situations where you need half a year of onboarding until they can really effectively work with your solution. So being able to self-service a lot, allowing your staff to work with as much of functionality as possible without requiring some dedicated deep technology stuff that is very deep into the technology to also customize certain functionalities, feature sets, is quite important also when it comes to efficiency and operational excellence in the end. Exactly, but also one thing then, and that's also already pointing into what comes next with the next presentations that you can expect, is the aspect of analytics. Because it's not only relevant for then building your feature set on top of your platform, your new services that you want to create, by then turning your data that you've gathered through these devices into valuable insights and building then solutions out of it that you then can sell. But actually, this can also be used to even increase the efficiency in your device lifecycle management process. For example, you can apply algorithms to calculate health scores to even be quicker in analyzing the current state of your device fleet. Or, for example, you can trigger automatic actions depending on certain behavior of your device, for example, to automatically trigger a restart or reapplying software packages if the rollout was incorrect due to any kind of reason. Yeah. With that, I'm already at the end of my presentation. I hope I was able to provide a good overview of various different aspects to consider. And I hope that you found it interesting and helpful for your process and for your IoT journey. And with that, I'm already handing back to you, Alex.
Great, Aaron. Thank you for that presentation and that overview. I hope it was very helpful for our audience. But thank you all for attending today. Aaron, thank you for presenting, and I hope everyone has a great rest of your day.